Hi dear students, welcome to Exam Side Mathematics by Pani. Here the question from sequence and series, we are in exercise 8D. The first question, find the sum to infinity of the geometric progression. See, what is the formula for sum to infinity in GP? Sum to infinity in GP denoted by S infinity, which is equal to A by 1 minus R, where A is the first term, R is the common ratio. So find out first what is the given series is 1, 1 by 3, 1 by 9. So first A is equal to 1. The common ratio equal to T2 by T1, which is equal to T3 by T2 and so on. So this is T1, this is T2, this is T3. Okay, dear students, I hope you understand. So any one of them we will calculate. Anyway, it will be 1 by 3 by 1. So 1 by 3. Even if you calculate 1 by 9 by 1 by 3 is also, we will get 1 by 3 itself. So our value is 1 by 3. Okay, dear students. So substitute in this. S infinity is equal to A value is 1 by 1 minus 1 by 3. So which is equal to 1 by 1 minus 1 by 3 is 2 by 3. Which is equal to 3 by 2. 3 by 2 means what? 1.5. So therefore the sum to infinity of the given geometrical progression is 1.5. Okay, dear students. Hi dear students. Here question from sequence and series, find the sum to infinity of the geometric progression. 6, 1.2, and so on, 0.24, and so on. Sum to infinity formula is S infinity equal to A by 1 minus R. A is the first term, R is the common ratio. So 6, 1.2, 0.24, and so on. So A is equal to T1, this is T2, this is T3. So A value we got it here clearly 6, and common ratio R is equal to T2 by T1. So 1.2 divided by 6, this is equal to 0.2. Even if we want to calculate 0.24 by 1.2, again we are getting 0.2, dear students. So therefore, even if you want to check, you can T3 by T2, that is equal to 0.24 by 0.12. Sorry, 1.2. Even itself also 0.2. So therefore sum to infinity S infinity equal to A by 1 minus R. A by 1 minus R. A value 6 by 1 minus R value 0.2. So which is equal to 6 by 0.8. 6 by 8 by 10. Which is equal to 60 by 8. So what we can do here? Directly, see, we are going to simplify 4 15s, 4 2s. So 7.5. Therefore, sum to infinity of the given series is 7.5. Okay, dear students, thank you. Please like and share to the needy students. 5, 20 by 7, 80 by 49, and so on. Find the sum to infinity of the geometric progression. See, here this is the first term A, second term T2, third term T3. So A is equal to here 5 and common ratio T2 by T1. No need to calculate every time T3 by T2. We get. So 20 by 7 by 5 by A1. That means 4 by 7 gets to 5 ones, 5 fours, 4 by 7. So, sum to infinity equal to A by 1 minus R. So, A value 5 divided by 1 minus 4 by 7. So, 5 divided by 7 minus 4 is 3, 3 by 7. So, 7 denominator of denominator, numerator, no, 7 5s are 35 divided by 3. Therefore, sum to infinity of the geometric progression is 35 by 3. Thank you, dear students. Please like and subscribe to our channel. Yeah. Hi dear students, welcome to exam side mathematics by Pani. Here the question from sequence and series. Find the sum to infinity of the geometric progression. See here, according to the geometric progression, minus 3 by 4, this is the first term A and T1. Second term 3 by 16, this is T2. Minus 3 by 64, this is T3, and so on. A value we already wrote. So common ratio can calculate T2 by T1, that is equal to 3 by 16 divided by minus 3 by 4. So 3 by 16 into minus 4 by 3. 3 get cancelled, 4 ones 4 4. So minus 1 by 4. So after that you can substitute in S infinity. Therefore sum to infinity A by 1 minus R equal to A value minus 3 by 4 divided by 1 minus of minus 1 by 4. So minus 3 by 4, dear students. Minus into minus is plus. So 4 plus 1, 5, 5 by 4. So 4 get cancelled, minus 3 by 5. Therefore sum to infinity is minus 3 by 5. Please like and share and subscribe to our channel. Thank you. Hi dear students, welcome to exam side mathematics by Pani. Here the question from sequence and series, we are in exercise 8D. Question number 5. Prove that 3 power 1 by 2 into 3 power 1 by 4 into 3 power 1 by 8 and so on equal to 3. So you have to consider LHS. So 3 power 1 by 2 into 3 power 1 by 4 into 3 power 1 by 8 and so on. Bases are equal, both should be added. So it will becomes 3 power 1 by 2 plus 1 by 4 plus 1 by 8 plus and so on. So the power of 3 can be written as 3 power 1 by 2 plus 1 by 4 can be written as 1 by 2 whole square plus 1 by 8 can be written as 1 by 2 whole cube plus and so on. We observe that this power is sum to infinity in GP. Now consider 1 by 2 plus 1 by 2 whole square plus 1 by 2 whole cube plus and so on up to and so on is sum to infinity in GP. Sum to infinity in geometric progression. Sir, how can you say that this is sum to infinity? Clearly, the first term A is equal to 1 by 2. So, T2 by T1 is equal to common ratio. So, even that also 1 by 4 by 1 by 2. Is it equal to 1 by 2 or not, dear students? So, 1 by 2. So, clearly we are observing. Therefore, this value, the power value 1 by 2 plus 1 by 2 whole square plus 1 by 2 whole cube plus and so on equal to A by 1 minus R. A value is 1 by 2 by 1 minus 1 by 2. So it will be 1. So wherever the power is there, this value replace with 1. 1 by 2 plus 1 by 2 whole square plus 1 by 2 whole cube plus and so on. That value is equal to how much? 1. Therefore 3 power 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus and so on is equal to 3 power 1. That is equal to 3 required RHS. Hence proved, dear students. Hence proved. Please like and share, dear students, about our channel. Thank you. Hi dear students, welcome to exam side mathematics by Pani. Here the question is from sequence and series in exercise 8D, last question. Let x is equal to, given x is equal to 1 plus a square plus and so on. By observing this x value, first term is 1 and common ratio is a only, no? T2 by T1, T3 by T2 and so on, if you see that. So is it equal to sum to infinity? Sum to infinity formula A by 1 minus R. According to here, A is the first term, that value is equal to 1. Common ratio R is equal to T2 by T1, that is equal to A. Substitute in this. So A value 1, 1 minus A. So X value we got it. From this, here anyway AB value I want know. So from here, what we have to do is 1 minus A makes subject is equal to 1 by X. So 1 minus 1 by X is equal to A. So A value we got it. Similarly, Y also you can consider like this, dear students. Y is equal to 1 plus B squared plus and so on up to infinity. This is also sum to infinity formula, A by 1 minus R. In this case, A is the first term equal to 1 clearly, and common ratio R is equal to T2 by T1, T3 by T2, R is equal to B. Okay, dear students, later, so Y equal to A value is 1, 1 minus B. So from this, you can conclude that 1 minus B is equal to 1 by Y. So 1 minus 1 by Y is equal to B. Now consider the required LHS. They are asking to prove this result. No. LHS value. 1 plus AB plus A square B square means AB whole square plus and so on. Even this is also sum to infinity in CP. Okay, dear students. So here also I am writing the same formula, A by 1 minus R, but based on the sequence it changes. A is the first term as 1 here, and common ratio R is equal to AB. So wherever A is there replaced with 1 and R is there replaced with AB. So which is equal to 1 by 1 minus R value is AB. So AB value we got it now here. This is A value, this is B value. Substitute in this 1 by 1 minus 1 by X into 1 minus 1 by Y. So we need to simplify. 1 divided by 1 minus, keep bracket, 1 minus 1 by Y minus 1 by X plus 1 by XY. So which is equal to 1 by 1 minus 1 plus 1 by X plus 1 by Y minus 1 by XY. So these two will be cancelled. Now take LCM. Denominator XY will become as a numerator. So here remaining is Y plus X minus 1. So this is required RHS. We can write like this also now. XY by X plus Y minus 1, which is required RHS, dear students. Hence proved. This is important for 4 marks we can expect, dear students. Thank you for watching our channel.